2015 after helping launch a cybersecurity startup that was subsequently acquired. Sabi is quite the person, and you'll find out very soon. And I'm asking you for just 20 minutes of your time to be listening to us here because we're going to talk about how he is truly changing the world of oncology and medicine. He has served in the past as Chief Strategy Officer at the Medical Futurist, where he led thought leadership initiatives before turning his focus to Turbine's quest for virtual cells. Although entering the field with what he describes as an outside energy, Sabi has steered Turbine through multiple top pharma partnerships, including Bayer, AstraZeneca, and Merck, and several financing rounds, all leading up to this latest $25 million Series B round, led by Interactive Venture Partners and Biostorf, and of course also joined by existing investors Axel and Merck. Welcome to the podcast, Sabi.
Thanks for having me. Appreciate that great kickoff.
So, Zabi, we're trying to keep the energy high here because we're doing it live so that anyone who's scrolling in their feed will hopefully stop and say, oh my God, who's this guy? He's quite impressive. Tell me a bit about your journey and how you started in 2015 doing virtual sales at a time where everyone is like, this is never going to happen. This is never going to work.
Yeah, I just want to make 2 points. One is I'll try to speak real fast because that's a superpower, and the other is that, of course, it wasn't really like my personal story. It was the effort of a team of scientists that I joined and helped catalyze a spin-off from a medical university in Budapest. And the original idea was, could we take what's done in labs and animals today, experiments to understand disease and help identify novel therapeutics to treat it, and could we essentially put it into a computer simulation? Could we create something that's predictive of what will happen in a lab, so you don't actually have to start by running an experiment in sort of cells and animals, but you can start by a computer simulation and thus really run more of an engineering process where you're sort of rationally understanding the disease you're targeting, and you can select the right experiment to run, the right drug to develop, and then of course the right patient to target with it before running any actual physical work. And that's what really catalyzed the initiation of Turbine.
Sabi, can you give us all an understanding of what is the direct impact here for someone using Turbine, or how much are you shortening timelines and so on?
Yeah, absolutely. So, like what you can imagine, and of course, people generally know this, is that drug discovery and development is a long process with usually 2 to 3 billion per drug that's approved spent, primarily not really even on the drug, but actually, excuse me, the failed drug discovery programs and clinical trials that were done on other programs that didn't work out, and so every individual drug has to make that essentially back and then some to make the biopharma business model work. And so the reason that it's so long and so failure prone, which is like typically 90% plus failure rates across the entire process, even in the very, very costly clinical trial phases. So the reason that it's so incredibly complex and long and failure prone is because biology is so incredibly complex and we don't really understand it as a system, right? I mean, we know a lot about it and we have amazing tools now, especially in the past like 10, 20 years, like CRISPR, all kinds of imaging techniques and sequencing techniques to understand it, or to, let's say, measure it and take snapshots of it, but the whole system in its full complexity we don't really understand. And so the problem we chose to work on was, can we create an AI based virtual cell that can, at the very least on the cellular level, understand what the hell is going on and help a drug discovery scientist and team predict the experiment that they're likely to run. And the benefit is sort of threefold, right? There's the primary benefit is that it can give you new ideas because, of course, essentially by creating a simulated experiment, a virtual experiment, we remove the physical barrier of having to actually wait for a lab to run experiments, often for months and months and months, and be limited in the number of experiments you can run, because no matter how automated your lab is, you're only looking at hundreds, maybe thousands, at the very, very, very best, maybe millions of conditions that you can test, but you're talking about a search space that's like trillions large. So there's no way that you can really cover every potential experiment. As a scientist, you have to always pick. And when you pick, that essentially, means that you have to go off of existing scientific knowledge, your own knowledge, and ultimately you bias what you find. And of course, by moving this all to a simulation, we allow a scientist to test any idea they may have, or essentially every potential, and it's just coming at the speed and scale and price of compute. and that allows them to find new things. And we have over 100 sort of novel pieces of IP that we've identified over the years using simulation. So that's the core benefit. But the secondary benefit that we're really now focusing more and more on, that's what this round is also about, is how do we make these simulations that we've really used as a research tool in the past, how do we make them a standard part of the workflow of biopharma, and how do we enable really the actual scientists on the other side to be running a more rational and engineering process, and ultimately just run the experiments that make the most sense, just work on the biology, the drugs that have the highest likelihood of working out and then actually translating to a patient benefit. And so there we've shown just recently that we can essentially cut the number of experiments in half and still get you the same result. And of course, this is an early application, and so we hope to over time show that certain experiments don't even have to be run at all because the simulation is predictive enough that you can just skip a certain part of the process, then be much faster. And again, just go to the higher signal, more likely to validate, or more likely to really work out experiments and model systems in the lab that you should be focusing your time on as a scientist. And of course, the third benefit we hope to show is that by being able to run all these experiments, really understand what the hell is going on in every single simulated experiment, simulated cell that you test. As a biologist, you should be able to more deeply understand the disease that you're targeting and better refine your patient selection protocol when you actually enter the clinical trial. And that should result in a higher likelihood of success. And so, the grand vision is that ultimately by developing this technology, and of course many other sort of adjacent solutions to be solved by AI, we contribute to really changing the economics of the biopharma industry because we essentially enable a much higher chance of success, much lower cost development. And that should mean that much smaller organizations, more nimble organizations can also develop new drugs, maybe targeted at a much smaller set of patients, but actually benefiting them proportionately more. And so that should in a way change the landscape of biopharma and ultimately get many more drugs essentially to market
Yeah.
for the patients.
Am I right in saying that you are in the process or have transitioned from doing discovery collaborations with the pharma companies to
Mhm.
actually selling the virtual assets? And maybe you can talk a bit about how that is how meaningful that is and how it's unlocking a next step growth for you.
Yeah, absolutely. So we announced a number of collaborations in the past like 6 to 9 months. You mentioned some of them. Merck and AstraZeneca are the two big ones. We also announced a big top 10 pharma company that we're working on a non-cancer related topic with now, and that was a big step forward for us, which we've always been a cancer predictor, and now we've been able to move to other cell types, other disease areas as well. So that was meaningful. But essentially, all of these collaborations are now about taking our simulators and integrating them essentially through a user interface and various APIs into the infrastructure layer
And
of these biopharma companies.
so in a way, you're becoming, instead of being a partner with your own team that helps do things, you're becoming just a tool that they use and they know how to use.
Essentially, you want to be the boring infrastructure play that actually everybody uses all the time, and thus you should be able to unlock much more benefit because you're not just changing, the workflow of a couple teams of scientists that we have over here in Budapest, but you're changing the workflow of the entire industry. Yeah, that's the goal. That's actually always been the goal. Funnily enough, when we launched in 2015, that was the idea. It's just that the technology was not yet ready. Absolutely, at the time, it wasn't scalable enough or predictive enough across enough like types of experiments that we wanted to virtualize. And then the second problem was that the market really wasn't there at the time. Even
Yeah.
applying AI to the still very hard but much simpler problem of like designing molecules, for example, which has matured, greatly since then and garnered a few Nobel prizes. Even that was like nowhere near essentially completion or achievement when we started out. And so we essentially picked one of the hardest problems that you could pick that anybody has worked on in the
Yeah.
past 5 to 10 years. And we picked it ahead of time, but that also meant that we, of course, had to put in a lot of the work to pioneer the technology, and now we had essentially have to pioneer the business model around it.
Yeah. Every time you transition from one business model, so to say, to another, you have
Mhm.
this, okay, what do you do with old partnerships? What do you do with the usual way of doing business to the new one? How are you managing that? I think there's a lot of founders out there that are always like finding the next way to monetize, finding the next business model in how they leverage their technology. But that oftentimes means that you have redundant or old partnerships that are harder to maybe deliver on.
Yeah, no, 100%. I mean, the like essentially what we are now doing is, so, funnily enough, as you think about it, the applications that we've sold to partners are the most mature applications, and we essentially started by productizing mostly those applications. And what that allows us to do is essentially go back to these partners and say, listen, you've seen that this works because we've been working in some cases for years, so for like multi-million-dollar collaborations on like using this technology, and you've now grown more accustomed to the benefits of having this and having access to this. Now we've essentially enabled your scientists to work, first alongside us, and then of course eventually without us. And so we've now envisioned a model, something like, let's say, Palantir's model, where you have an initial deployment phase where you do go in and you do a lot of hand holding, and you make sure that your system can work with their data sets, you have the right interfaces set up, and you educate the users. But after that, they should be able to take our predictive virtual cell-based assays essentially and integrate them into their day-to-day workflow, and they should be able to do the job. And that's, I would say that people are listening with open ears to that, and we're in the process of transitioning some of these customers to this new model.
Let me ask you about going, so to say, wider, the horizontal potential in this. And I think it's probably, we can tie it to your funding round, because your Series B was just led by Beiersdorf Venture Capital. And they are, of course, in a different space than some of the others. And then you have a heavyweight like Axel that comes from Pure Venture, and MSD, of course, as well. I'd love to hear, like, going from oncology into now also being able to really be backed by someone who's doing global skincare. What does that mean for where your technology can go?
Yeah, the funny thing is that honestly, we were the most surprised when Beiersdorf's great team reached out a couple of months back to ask whether we would consider getting an investment from them, because we were like, why would you want virtual cells in your R&D process? But then what we found out was that essentially dermatology and cosmetics often uses, I mean, those companies that do real research there for active ingredients, what they actually do is very, very similar to the biopharma process. So they use almost the exact same tools. They use CRISPR to knock out genes. They use certain automated tests to test various active ingredients and molecules on the biological model systems in a lab. And so that's very, very similar to biopharma. They, of course, have different constraints. For example, they can't do animal experiments because, of course, it would not be ethical to use it not for life-saving, like purposes. So in a way, it turned out that the process they run is almost the exact same as what we were supporting with biopharma. And so what we, with our recent technology advances, as you said, we've already enabled us to not just predict cancer and in all its forms, but to predict any type of cellular behavior. And with that step forward, we essentially now could set up cells like, for example, immune cells. And it turns out that skincare is essentially just another bunch of cells in a petri dish of some sort. And so we've started the, like, let's say, discussions around how could we develop predictive models of the types of biology that the cosmetics industry would care about. And of course, like, I have to stress that at this point they only invested in Termine, but really of course, like, our underlying interest in taking their investment was also that they bring a ton of understanding of a completely new industry that is maybe not as large for us at this point as the biopharma industry, but there's plenty of space there to actually impact a more consumer-facing application that could take the same technology and really show that it has multi-industry potential, which of course thus really drives home the message that we're changing the game in understanding biology across many industries.
Yeah. Let me ask you, we do a ton of work with UVC on bringing together the venture and the corporate community, because we think that there's so much to learn from both sides, and also from founders to be seriously considering corporate capital. But there are also things that you got to know when you do so. I'd love to hear from you, like, what are your do's and don'ts and the learnings from working so closely with corporate venture?
Yeah. I mean, actually, we have a bunch of essentially corporate venture capitalists on the board, because we also we were invested into by MassMutual, for example. Of course, they've now transitioned their global investments to Crane, but still, like, MassMutual was there. As you said, Merck, like MSD, Merck in the US is also there. So what honestly for us it's been really really beneficial because I mean you yourself mentioned that we've launched out of university 10 years ago, right? And that means that of course for a long time we were bootstrapping, and a lot of the I think a lot of the 10 years is down to us being a team from an ecosystem that doesn't have biotech, doesn't have deep tech funding, and sort of had to really learn some of the hard lessons that weren't available where we started. But and also like the funding was not there, et cetera, et cetera. But even then, it took us a long time to actually really perfect the technology and make it market ready through deep tech in that sense, like developing
Yeah.
novel like machine learning architectures, data generation approaches, et cetera. And so we need investors that have the staying power essentially and the patience for that, and we needed investors that really understood the markets that we were going to sell into, since of course we are really none of us are biopharma people, right? And that essentially means that we really have to as outsiders learn about this new industry and find the right connections. And I've found that the CVCs we've worked with have been really really helpful in that sense, and we've had like almost minimal, like quite honestly minimal issues with like decision making processes and whatever. I'm sure that that's very CVC dependent, but we haven't really
Yeah.
seen that except like maybe one or two like very specific clauses that you need to include in like the
Yeah. Yeah.
shareholders.
Well, pharma is exactly the place where I think a lot of founders can look to understand how a really good corporate's doing this, and then of course from the founder side understand from founders who have taken that money, what did you think about, what are you aware of, and those types of things. So I think you're on point here, absolutely. Let me ask you the final question here. I'd love to hear about your vision, because the goal, of course, is to turn biology into an engineering discipline. But as you're scaling now to toward 100 employees, what's the biggest hurdle that you're finding in making virtual experiments the industry standard for the next 5 years?
Yeah, I mean, it's really this very interesting transition that we worked towards for a long time, because for years and years we were hacking away at the technology and always dreaming about the chance when biopharma would be looking for this as a standard tool, and we would be able to actually deliver it. And now we're there, and it's a really exciting time because we're truly going to market. We're racking up new customers by the day, and it's a really exciting time. But also the challenge is that of course now suddenly you meet the let's say the treacherous road that leads to actual usage by real customers that sit outside your organization, and you also need to find the the right way to essentially take something so novel and make it part of the workflow today. And that took us, I think, years to really figure out like what is the go to market here, because we wanted to simulate all kinds of different things. Ultimately, we hope that we'll be able to simulate a patient and provide like patient level predictions that help like guide their treatments. And for a long time, I think we made the mistake of trying to cram too many of these technical directions as well as like messages essentially to our communication to pharma, as well as our like research focus. We were just too scattered across these many applications, and a lot of these are really visionary, and we do believe that we'll get there, but you can't substantiate them today. So if somebody asks you, can you show me proof that you can predict a patient's behavior, you know I may have some super rough and early research results, but I won't have a compelling evidence package that I can show them, nor can I tell them how to measure my technology, which is so new that they need confidence in it. So how to measure that today, right? Or like tomorrow. They can measure it a couple of years out if I'm talking about patient
Yeah.
response. But when we realize that we should actually say, listen, this is a virtual assay that actually just virtualizes the stuff you already do in a lab, maybe in an animal, that subtly catalyzed a very different like focus for our tech roadmap, as well as adoption by the industry, because it's something that delivers clear ROI today. It's cuts down significantly on the number of experiments, speeds up your decisions by months and quarters, and that's like real money, real impact today, and this can be substantiated much more easily. So I think that transition is what really got us started. But in terms of the vision, as you ask, the challenge will be, okay, well, how do we not get bogged down in a very actionable but relevant technology today, and how do we keep ahead of this um, like more and more aggressive competition to build more and more predictive models of biology that capture more and more of the complexity of the entire sort of human organism. And we could very easily find ourselves in a situation where we're sort of pigeonholed into a virtual cell company, and somebody builds a virtual human, and suddenly we're disrupted. So I think keeping up with that pace of tech change will be key. And then I think a really exciting part of this is figuring out how to take our predictions and make them part of the regulatory process. Because once we do that, and once we become part of a regulatory package that pharma sort of issues, and the regulators open up to accepting in silico simulated data, not just real like experimental data, that's when you become, that's when you have true lock-in and the true staying power, and the competitive mode. But we have to get there, and that's a lot of,
Yeah.
policy impact, a lot of education on the market.
Sabi, I'd love to ask you on the talent side, you're building
Mhm.
out of Budapest. We're building in a space here that is in the intersection point of engineering and biology. How is it to find talent here? Is it quite simple? Is it difficult? Do you have to attract people to come
Mhm.
from all over the world? How do you do it?
Yeah. So at this point, what we found is, let's say, Central Eastern Europe is a really strong regional talent pool, because, as you said, I mean, we're now about 80 people going to 100. we we don't yet need hundreds and hundreds of people yet. So for now, we find that this is like ample enough available talent. And the really cool thing is that none of our competitors are even remotely here. Most of them are over there in the US. And so when we say, you're a machine learning scientist, of course you could get a job anywhere essentially today, but you could work on changing the game in the cancer care, and really understanding biology, which is such a fundamental challenge. Like, that's a huge draw when we are attracting talent. At least we found that we haven't really struggled for attracting the most, the keyest positions, I guess. But we also really started spreading the team wider. Of course, many of us are still here in the HQ in Budapest, and we actually, let's say, repatriated a number of Hungarians that were elsewhere. Plus, we've also brought in a number of really, really key experts from abroad to be located here. But we've also now set up more of a virtual set of teams essentially around the rest of Europe. But let's say, we're very early in that journey. So I think local regional talent pool for computer science, machine learning, and even biology and lab, that's ample enough for now. But I think some key positions, for example, product in such a very specific industry, we've had to go to, for example, the UK to get that, and that definitely has been more of a challenge.
Yeah, incredibly exciting. Tab, could I ask you, just like anyone who tuned in today, any specific messages you'd like us to close with before we say goodbye?
Yeah, I'd say I think it's really worth investing into deep tech in Europe. I mean, we're just in one pocket, of course, of this very sprawling term, but our experience really shows that there's some really, really cool science that can turn into extremely impactful and lucrative technologies. But I think we as a continent, and we as sort of I guess an industry, need to do more to help the next generation of such founders get started and really learn more from the US in how they invest into like groundbreaking science that can eventually turn into huge products and huge new markets. I think that's something that we actually, even as founders, are doing more advocacy around, and helping out more sort of next generation entrepreneurs, because I think it's so important, as we found that getting those early lessons, getting that help, getting the funding and the connections, that was the sort of half the time that we spent in the past 10 years, and it could have been so much faster.
Yeah, incredibly. Yeah, could not agree more. Sabri, thank you so much for joining me today. Anyone who tuned in today, if you are working in any way on virtual simulations and thinking about how it might be able to de-risk your R&D pipeline, I do absolutely suggest that you go and check out the virtual lab by going to turbine.ai. And of course, anyone who is hoping to build a career in engineering and biology, make sure to go to turbine.ai/careers. And of course, finally, follow up if you are looking to keep up to date with everything that's happening in this exciting space. Do make sure to subscribe to the Blue Sky page of Sabi and the team, as well as, of course, Turbine's beautiful LinkedIn page. Thank you, everyone, so much for tuning in today. I hope you enjoyed it as much as I did. Sabi, thank you for doing the important work you're doing. I know that a lot of us are affected in some way by terrible diseases that you're helping cure. So thank you so much for that.
Amen. Appreciate it. Thank you so much.
Indeed.